Have you ever stood next to a massive container ship and just wondered about the engine inside? I mean, we're talking about a beast of metal that's several stories tall with enough power to push hundreds of thousands of tons across an entire ocean. But how in the world do you start something that big? You can't just turn a key. So today, we're going to dive into the incredible pneumatic ballet that brings these giants to life.
All right, so to get there, we first have to wrap our heads around the massive challenge we're even trying to solve.
Okay, think about your car. A small electric motor has just enough juice to get the engine turning, but on a ship, the scale is on a completely different planet. The sheer weight, the inertia, the incredible compression inside those massive cylinders, an electric starter wouldn't even make it budge. It'd be like trying to push-start a skyscraper. So engineers turned to something way more powerful. A huge blast of high-pressure air at about 30 bar shot directly into the cylinders to literally force those giant pistons down.
Now, what's really cool about this whole thing is that it's not just about brute force. Nope, the solution is actually a super clever two-part system that works in perfect harmony.
The easiest way to think about it is brains versus brawn. On one hand, you've got the main starting air system. That's the brawn. These are the big pipes carrying all the high-pressure air that provides the actual muscle to turn the engine. But on the other hand, you've got the control air system, and that's the brains. It's a smaller network that sends these little, precise signals of air, kind of like a nervous system, telling all the heavy-duty main valves exactly when to open and close.
To really get this, we need to meet the key components. Let's think of them as characters in a very well-rehearsed play.
First up, you've got the heavy hitters of the main system. The main stop valve, that's the manual gate the crew opens to let the power into the system in the first place. But the real star here is the automatic valve. Just think of it like a master security gate held shut by a huge spring, blocking all of that immense 30 bar pressure until it gets the very specific go command from the brains of the operation.
So where does it all begin? Well, it starts with a person, the marine engineer. When they move the starting lever, that's the command that kicks everything off. This lever physically pushes on the pilot valve, which is basically the first domino in a long chain. It just cracks open a tiny bit to send a small, targeted puff of control air into the brain of the system, waking everybody up.
But all that power is useless if you don't have perfect timing, right? That's where the distributor comes in. As the engine starts to turn, a distributor cam, which is basically a physical map of the engine's firing order, rotates right along with it. The distributor reads this map and acts like a traffic cop, making sure that the control air signal only goes to the one cylinder that's in the perfect spot for its power stroke. It's a beautifully simple mechanical computer.
And this is where it all comes together beautifully. At each cylinder, you've got an air starting valve. The high-pressure main air, the brawn, is sitting right outside, just waiting. When that perfectly timed little pulse of control air, the brains, arrives from the distributor, it pushes the valve open and bam! The main air blasts into the cylinder, shoving the piston down with incredible force and turning that crankshaft.
Okay, so we've met the players. Now let's see the play. We're going to trace the path of the air, step by step, from the engineer's lever all the way to the engine's first roar.
So before anything happens, the whole system is in standby. The crew's already opened the main stop valve, so the system is charged with 30 bar of air. That immense pressure, you see it there in red, is just waiting behind two locked gates, the big, tough automatic valve and the tiny little pilot valve. The engine is literally holding its breath, waiting for the command.
And here we go! The engineer pulls the lever to start. The first domino falls, the pilot valve cracks open. This releases that small but absolutely critical control air signal. That's the blue line. That signal does two things at once. It races to the top of the big automatic valve, and it also primes the timing distributor. This tiny puff of air is all it takes to overpower that heavy spring on the automatic valve and push it open.
Now the floodgates are open. With the automatic valve open, the main high-pressure air, the brawn, surges through the main lines and waits right outside each cylinder. Then the distributor, the brains, sends its perfectly timed pulse of control air to the correct air starting valve. That valve opens, the main air blasts in, and the engine starts to turn over, one powerful puff at a time, getting faster and faster until it can finally start firing on its own fuel.
And we have success. The engine has caught, it's running on fuel now. So the engineer moves the lever over to the run position. This immediately closes the pilot valve, which cuts off the control air supply. But what about all that air trapped in the lines? Well, as you can see with those green arrows, the valves are designed to safely vent all that trapped control air out to the atmosphere. And without that air holding it open, the big automatic valve slams shut, and the whole system resets itself, ready for next time.
So the really crucial thing here is how this all connects. It's a flawless chain of events, all starting with a simple human action and ending in immense mechanical power. Let's just look at this one last time. It really is a perfect chain of command. The starting lever pushes the pilot valve. The pilot valve sends out two signals, one to open the automatic valve to let the main air through, and another to get the distributor ready. The distributor then sends that final, perfectly timed pulse to the air starting valve, which unleashes the main air to fire the cylinder. It's just a masterpiece of pneumatic logic.
So the next time you see a massive ship gliding across the horizon, you'll know its secret. You'll know it wasn't a key or a button, but a beautifully orchestrated blast of air, flawlessly turning precise pneumatic logic into the raw mechanical power that is the very heartbeat of our global economy. It really makes you wonder, what other simple systems are out there, hiding this level of brilliant engineering?